Hi everyone, welcome to today's tutorial. So if you have not yet subscribed to the channel, make sure that you do so by clicking on the subscription button. And then if at all you have any questions or you need help or you need tuitions in mathematics or physics, feel free to contact me on these lines on the screen. Alright, so let's quickly begin to solve the question. So the question says, determine the tensions in the two ropes attached to the rigid support in the system are shown. So if the supported blocks are in equilibrium. So this one is straightforward as well. So how do we do it? The first thing in physics, when you're solving any question, you have to draw a free body diagram. So I have 100 newtons in the Y. Then I also have this tension there, which is at 60 degrees angle. Then we also have this one, which is in the X. So we are going to draw that. So if this is 60 here, when you follow the Z angle properties, this part will also be 60 degrees. So I'm going to use this triangle to resolve the components of my T1, and then this one T2 is simply just in the X. So we'll start first by finding all the forces in the X. Say all the forces in the X should be equal to 0. So the force, this force T1 in the X, by using SOHCAHTOA, we know that SOHCAHTOA, this is how we write SOHCAHTOA. Then in the X, we know to say we have been given T1, which is the hypotenuse, and then the X component will be the adjacent to 60 degrees. So the X component will be the adjacent to 60. So we're going to say cos 60 degrees is equal to the adjacent, which is this, which is just T1 in the X, and then divided by the hypotenuse, which is just T1. So if we make T1 in the X as a subject, the answer will simply just be T1 cos 60. So the answer will just be T1 cos 60. So now from here we can write it now in the formula. So this is one of the X components that we have. So we have T1 cos 60 degrees, and then we have T1 cos 60 degrees, and then we also have this T2, which is directed in the negative X. So we say minus T2 is equal to 0. So we make T2 the subject in this equation. So say T2 is equal to T1, we have T1 cos 60. So T1 cos 60, this is just the same as 0.5 times T1. Alright, so so this is, so we know that T2 is given by the formula 0.5 times T1. Let us now quickly find the summation of forces in the Y. So this should also add up to 0. So in the Y we have 100, which is directed to the negative of the Y axis, so we put a negative on 100. And then we also have the Y component of T1. So the Y component of T1, since the X component was T1 cos 60, the Y component will be T1, it is in the positive of the Y, so I'm going to say positive T1 sine 60. Then we say this is equal to 0, because these are the only forces that we have in the Y. So we can make T1 the subject. So when we make T1 the subject, we have T1 sine 60 is equal to, when you take the 100 to the other side of the equal sign, so we divide by sine 60, and then T1 will therefore be equal to, so when you divide 100 by sine 60, the answer will be 115.47. So the answer will be 115.47 newtons. So this one is for T1. So now to find T2, so T2 is now going to be found by just replacing T1 there. So how do we do that? Simple. So let me just demarcate just from here. So T2 will therefore be equal to, so T2 will therefore be equal to 0.5. Then my T1 is 115.47. So this implies that my T2 will therefore be equal to, when you multiply that by 0.5, the answer will be 57.73, or I mean 74. So we have 57.74 newtons. So my T2 is equal to 57.74 newtons. And then T1 is 115.47 newtons. Alright, so thank you very much for watching today's tutorial. Make sure that you subscribe to the channel, as you will be receiving information. So it's not always that I post all the videos that I solve in the group. Some of them I just post them direct on the channel. So for you to have access to that on the right time, you should subscribe to the channel. Just click on the subscription button there. So if you have any questions, feel free to contact me on any of the lines on the screen. So thank you very much for watching today's tutorial. My name is Harmtedy. Shalom, shalom.